Guys, all right, so this is lesson number 2 from our probability and stats unit. I'm calling it 10.2 since the other one was 10.1. All right, and today we're talking about probability of multiple events. Oh, and by the way, linked in Google Classroom is a PDF. It's from Big Ideas Math, and that's why we call it 10.2 because it's their 10.2. It's number, you're going to be doing numbers for homework: 3, 5, 7, 8, 12, 13, 18, and 21. Okay, so that's the homework. And that, of course, will also be in Google Classroom. Okay, but I mean, at least if you have it right down here, then you don't need to keep looking for it. All right, so again, today we are looking at probability of multiple events. I'm going to color these up because it's fun. And I get to use these really cool, well, they are Star Wars, like that's an Ewok on there. I don't know if you guys can see. But anyways, I got a target. So excited. All right, anyways, 2 events are independent if the occurrence of one has no effect on the occurrence of the other. When the occurrence of one event does not affect the occurrence of the other, they are called independent events. So some more definitions to piggyback off of yesterday. If 2 events are independent, then you find the probability of each and you multiply them together. Find the probability of each and multiply them together. And that's for if 2 events are independent. Okay? So, when we're trying to find the probability of multiple things now, because we're looking at probability of multiple events, not just one event at a time now. When it's multiple events, if they are independent, to find the probability of them both happening, we multiply them together. That's what that means. Okay, so for instance, we have an example here, number 1. It says, what is the probability of rolling a 5 and then a 3 on the same die? Well, we need to look at them separately. That, and when you roll a die, the probability of rolling a 3 versus a 5, they have no effect on each other. If you roll a 5 the first time, that has no effect on if you roll a 3 the next time at all. So I need to look at the probability of rolling a 5 and the probability of rolling a 3 separately. Well, a die has 6 sides. 1, 2, 3, 4, 5, 6. So that's our total outcomes. A 5, there's only 1 5 on a die. So it has a probability of 1 out of 6. Well, a 3 is also on a die, a 6-sided die. So there's 6 total outcomes, and there's only 1 3 on that die. So its probability is also 1 out of 6. So this leads me to the probability of rolling a 5 and then a 3 is, well, the probability, since they're independent, probability of rolling a 5 is 1/6 times the probability of rolling a 3 is 1/6. So the probability of rolling a 5 and then a 3 is a 1 out of 36 chance, because you have to multiply across when you multiply fractions. And 1 times 1 is 1, 6 times 6 is 36. So you have a 1 out of 36 chance, but we also know that we have a tendency to want this as a decimal or a percent as well. The percent would be really, really, really small. 1 divided by 36 is 0.03 if I were rounding that to the nearest hundredth, which would mean if I move that decimal place over 2 places, that would be 3%. I know I boxed that weird. That's not really a box, like a trapezoid, but it's okay. So 1 over 36, or in other words, 0.03, or in other words, 3%, depending on how they want you to write your answer. Now, when you do your homework, you only need to write your answer in one way. It could be one of those 3 options: fraction, decimal, or percent. If it's a fraction, though, you have to make sure it is reduced. Okay. All right, number 2, what is the probability of having all 4 of your children be boys? Well, let's look at the probability of a boy, and we're going to have 4 boys. Well, that's a very loud house. All right. Well, you have 2 options. You're born a boy or you're born a girl, okay? So the probability of having a boy is 1 out of 2, okay? Just like flipping a coin, heads or tails. Probability is 1 out of 2. Well, now we want the probability of all 4 boys. Well, that means we've got 4 events going on here. Your first child's probability of being a boy is 1/2, times your second child's probability of being a boy is 1/2, times your third child's probability of being a boy is 1/2, times your fourth child's probability of being a boy is 1/2. Having a boy has no effect on what your future children are going to be. Having a boy or a girl does not affect your future children. Okay, it's a luck of the draw. It's probability. It's just by chance. So 1 times 1 times 1 times 1 is 1, and 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So you have a 1 in 16th chance of having all 4 boys. So that's the fraction. Or as a decimal, bring out my calculator again, 1 over 16 would be 0.06, just rounding it to the hundredths. Or as a percent, you move that decimal place over to the right twice, that would be 6%. Okay? Remember, I'm just putting all 3 for your notes. You only need to pick one way to write your answer for your homework, okay? All right, number 3. It says, what is the probability of drawing an ace and then replacing the card and drawing another ace? Okay, so we got a deck of cards here. So we're looking at the probability of an ace and then another ace. So ace and then ace. Okay, well, that means we need to know how many cards are in a deck. I'm pretty sure there are some of you listening to this video right now and you're like, oh, I know what the answer is. There are 52 cards in a deck of cards. So that's our total number of outcomes. Well, how many aces are there? Well, there's 4 suits, so there should be 4 of each kind, so 4 aces. Okay, so your probability of getting an ace the first time, okay, and then they put the card back. This word is important. They replace the card, so they put it back. So there's still 52 cards in the deck when he draws again, and that means that there's still 4 aces in the deck of cards, so the chances of getting it is still 4 out of 52. Well, pulling an ace and then an ace again is just 4 out of 52 times 4 out of 52. Now this one, I would not leave it as a fraction because it's going to be some big numbers down there in that denominator. 4 times 4 is 16, and 52 times 52, I'm going to need my calculator for that, is 2,704. Now, you can reduce that, but I would just write that as a decimal. That would be a lot easier. So 16 divided by 2,704 is I'm going to go out 3 decimal places because of those double zeros there. So I'm going to go 0.006. This is a really small number. So I have a 0.006 chance of drawing an ace and then an ace again. Or as a percent, we would have to move that decimal over to the right twice. So it would be 0.6%. Those are 2 ways that you could write your answer. Okay, so there's that one. All right, so those were independent events. They have no effect on each other. Drawing an ace and then drawing an ace again had no effect on each other because it was replaced. If it wasn't replaced, then it's still not going to affect, it's going to change the second fraction if it wasn't replaced, okay? And we'll talk about that in future problems. But drawing a card has no effect on future cards that you draw, okay? All right, so this next part, well, we talked about independent events, so now we got to talk about dependent events. 2 events are dependent if the occurrence of one has an effect on the occurrence of the other. In this case, the probability changes as you go. And that's what I was leading into when we were talking about drawing the ace if I wasn't replacing the card. Okay? So number 4, it says, what is the probability of drawing a king from a deck of cards? You keep the card, so you don't put it back this time, and then you draw a queen. Okay, well, we're looking at the probability of drawing a king and then a queen. And, oh, not kind. King, I don't know why I do that. I've always done that since I was a kid. All right, anyways, probability of drawing a king and then a queen, but we're keeping the card. We're not putting it back. So we're first drawing a king. Well, there's 52 cards in that deck, and 4 of them are kings because there's 4 suits in a deck of cards. So, like, what are they? Clubs, hearts, spades, diamonds? Yeah. So, the king of hearts, the king of spades, the king of clubs, the king of diamonds. So there's 4 kings. But we're not putting it back. Okay, so we have to multiply by the next probability. We're looking for a queen. Well, but now, since we didn't put that last card back, there's 51 cards in the deck, and we haven't pulled a queen yet, so that means that there's 4 queens in the deck. So now our probability, 4 times 4 is 16, over 52 times 51, 52 times 51 is 2,652. 2,652, and then because that fraction is so dang huge, we're going to just go for the decimal. So 16 divided by 2652 is 0.006 again. That's the straight up decimal. Or as a percent, you move that decimal over to the right twice, and it is 0.6%. All right, so that's number 5. Okay, number 4. So now we're on to number 5, and it says, what is the probability of getting a pair of black socks out of a messy sock drawer? The messy sock drawer has 20 socks. Of those 20 socks, 8 of them are black, 4 of them are white, 2 of them are red, 6 are striped. If you take the first sock, you put it aside. So that means you don't put it back, and you pull out the second sock. Okay, so I'm going to just go for the problem instead of writing out this beginning part, because we're trying to find the probability of getting a pair of black socks. A pair means we're talking about 2 black socks. So, I mean, I guess I could put that. So we'll just put probability of black and then black, and we're talking about the color of the socks. Okay. All right, so the probability of getting a black pair of socks. Well, there's 20 socks in the messy sock drawer. It's probably my son's sock drawer, although we only get him black socks so that he doesn't have to worry about matching them, because he will wear opposite colors all the time, and that's why we changed to all black. Anyways, there are 8 black in that messy drawer right now, so the probability of picking a black sock right now is 8 out of 20. But then we're gonna try to, eyes closed, reach in that drawer just like my son does, and see if he gets another black sock. Well, now there's 19 socks in the drawer because he put the other one aside. It's not in there anymore. So now there's 19 socks in the drawer, which means if he pulled out a black sock the first time, that means now there's 7 black socks that he could pull from. And that's our problem. So now we just got to multiply across. 8 times 7 is 56. 20 times 19, I won't be able to do that one in my head. Let's see, 20 times 19 is 380. And then, don't want to reduce that, so let's just get the decimal. So 56 divided by 380 is 0.15. Or we could write that as a percent, which would be 15%. All right, and that's what your homework is going to be about. So 10.2, the PDF attached in Google Classroom, numbers 3, 5, 7, 8, 12, 13, 18, and 21 on independent and dependent events. Have a good one.